Alright, so let's have a look at some of these questions again. This is tutorial worksheet number 2. Okay, so for the first question, again it's just simplifying the following expressions. So question 1a, we've got 3 to the power 4 times 27 to the power negative 2 times 128 to the power 4 times 64. Okay, so what we want to do here is find the prime factors of everything first. So the prime factors, 3 is already a prime number, so we can just keep that. Then 27 we can rewrite as 3 to the power 3. And that's to the power negative 2 all raised. 128 is the same as 2 to the power 7 raised to the power 4. And then 64 is 2 to the power 6. And for those of you who don't know, on most calculators these days, if you want to find, let's say you want to do 128, you want to find the prime factor, so you type in 128, then you type equals, then you press the shift button, and then you press the button that says fact on top of it for the second function, or for the shift function. And if you type this in, you should get 2 to the power 7 on your calculator. So that's a nice shortcut way to find the prime factors of any number. Alright, so let's get back to it. Now, we also know from our laws of exponents, if we're multiplying and the bases are the same, then we add the exponents. But first, before we get there, let's remember our laws of what comes first. So first, we do this. So 3 times negative 2 will be negative 6. And then here we can do 2 to the power 7 times 4 is 28. And then 2 to the power 6. Now we can do the addition part. So the 3's, we add 4 plus negative 6 is negative 2. And then the 2's, we get 28 plus 6 is 34. And also we want to leave our answers with positive exponents usually. So to do that, the 2 is positive, so that can stay at the top, 2 to the power 34. But the 3, we want to take this to the bottom, so the exponent sign changes. So it becomes 3 squared at the bottom. And then that is our answer in its simplest form. Okay, question B. So you see what we'll do here, just find the prime factors of everything first, then apply our laws of exponents, and then do the last bit of simplification. Okay, question B. So we've got x to the power negative 2 times y to the power, or y, times y over x to the power negative 3 times y to the power 5. All of this over x to the power 6, 1 over x to the power 4, 1 over x to the power 4, 1 over y to the power 6. 1 over y to the power 6. Okay, so at the top, let's first sort out this part here with the brackets. Well, from BODMAS we know we have to sort out that first, right? So let's just approach it that way. So we keep the x to the power negative 2, we keep the y, and then we do y to the power negative 3 over x to the power negative 3, and then y to the power 5. All of that over x to the power 6, and then we've got 1 to the power 4, so that's just 1, because 1 to the power anything is just 1, but let's write the 4 in for now. 1 to the power 4 over x to the power 4, and then we've got 1 to the power 6 over, let's do a proper 1 there, 1 to the power 6 over y to the power 6. Okay, so now let's sort out these fractions first. So we keep our x to the power negative 2, and then we've got y to the power 1, that's just this y. Then we've got y to the power negative 3, and then this x is at the bottom. So if we take this x to the power negative 3 to the top part here, then it becomes x to the power positive 3, and then y to the power 5. So just so that we don't have a fraction over a fraction, so just sort out the mini fraction on top out first. And then we can do the same at the bottom. So here we've got 1 to the power 4, so I'm just going to write 1. Then x to the power 4, if we take it to the top again, we get x to the power negative 4. And then the same here, we've got a 1 to the power 6, which is just 1. And then we've got y to the power negative 6 if we take that to the top. Okay, so again, these ones, you don't have to write the ones. Now, let's simplify the top. So we've got x's being multiplied. So it's negative 2 plus 3, right? The bases are the same, both are x's. And then we add the exponents. So negative 2 plus 3 is 1. So that's just x. And then we've got the y's at the top. So we've got 1 plus negative 3, which is negative 2. And negative 2 plus 5 is 3. Let me just rewrite that 3 so we can see it looks like a 3 actually. At the bottom, again the x's, we've got 6 plus negative 4, which is 2. And then the y's, we've got negative 4 plus negative 6, which is negative 10. Okay, so now we basically want to check where is the exponents the biggest. So for the x's, the biggest ones are at the bottom, right? So at the bottom, 2 minus that 1 will give us 1x at the bottom. And the y's are the biggest at the top. So we've got 3, and if we take this one to the top, or we can say 3 minus minus 10 is 13. Or we can just say if we take this to the top, it becomes y to the power of positive 10, and then 10 plus 3 is 13. So that's our answer for this one. Oops, we'll just do that so we can see the 13. Okay, great. So that was the second question, right? That was B. And then we do C. We'll do question C. For question C, we have a minus 2b over b. A minus 2b over b minus, and then 1 minus 2a over 2a. So 1 minus 2a over 2a. So again, adding or subtracting fractions, we want to get a common denominator. So we're going to have b and 2a. So we're going to have 2ab as our common denominator. So at the top, we had an a minus 2b for this fraction at the top. So what does it still need? At the moment it has a b, so it still needs a 2a, right? It's got the b part, so it still needs the 2a part. So we're going to multiply this by 2a. Minus, this one had a 1 minus 2a. What does this still need? Well, it's got the 2a, so it still needs the b. So this one still needs the b. Okay, let's multiply it. So a times 2a, that's 2a squared. And then negative 2b times 2a, it's going to be negative 4ab. And then here, so negative b times 1 is negative b. And then negative b times negative 2a is positive 2ab. All of this over 2ab. So now collect like terms at the top. So the a squared, that's 2a squared, that's fine, we can just keep that. No other a squareds. Then the ab's. So we've got negative 4ab plus 2ab, that's going to be negative 2ab, and then minus b. And at the bottom we've got 2ab. So is there a factor? Can we do any factorizing at the top? There's no common factor, there's no factorizing we can do at the top, so that's our final answer. Simplest form. Alright, so that was question C. Let's move up and do question D at the top. Question D. So we've got u to the power of half, u to the power half minus v to the power half. Okay, over, and we've got 2 u to the power 1 over 4 minus v to the power 1 over 4, and then u to the power 1 over 4 plus v to the power 1 over 4. Okay, so with fractions, if we can factorize, we want to factorize. So this part we can factorize. This is a difference between two squares, right? So at the top, so this we can factorize into two brackets. One gets a plus, one gets a minus. And then we have the square root of the first thing. So square root of u to the power half is u to the power quarter. So that goes in here. And then the square root of the second thing. So the square root of v to the power half is v to the power quarter. And you can always check just by multiplying this out that you'll get this back again. So this all over to u to the power quarter minus v to the power quarter. And then u to the power quarter plus v to the power quarter. Okay, and then we see this can cancel out with that, this can cancel out with that, and we're left with 1 over 2. And that's our answer. Okay, so difference between two squares, very nice factorizing method. Yes, that was question 1. Question 2. Question 2a. Okay, expand and simplify. Okay, so this is similar to what we did in the previous, in tutorial worksheet 1. So this is just multiplying out brackets. 2x minus 5 times x plus 2 times 3x plus 4. Oops, 3x plus 4. Got a plus. Okay, again, you can multiply any two brackets first and multiply that resulting answer with the remaining bracket. I'm going to do the first two brackets again. So 2x times x is 2x squared. 2x times 2 is 4x. Negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. And then 3x plus 4 is in the other bracket. 3x plus 4. Okay, let's collect our like terms inside. So 2x squared. In the x's, 4x minus 5x is minus 1x. And then minus 10. Multiply all of that by 3x plus 4. Okay, now we remember again, we take each term in the first bracket multiplied by every term in the second bracket. So we start off by these two. So that's going to give us 6x to the power 3. Then multiplied by the second thing, so that's going to be plus 8x squared. Then we've got minus x times 3x is minus 3x squared. Minus x times 4 is minus 4x. Negative 10 times 3x is negative 30x. And negative 10 times 4 is negative 40. And again, collect our like terms. So the x cubed, there's just that one term, so 6x cubed. Then the x squared, so 8x squared minus 3x squared is 5x squared. Then the x's, negative 4x minus 30x is negative 34x. And then we've got our negative 40, our constant. And that's our answer. Okay. Next up, we have b. So b is a plus 1 squared. Where's my pen? There we go. So we've got a plus 1 squared. Where am I? And then 2a plus 1. 2a plus 1. So again, multiply anything first. So we want to do the square first. But you can also write the bracket, just write out the bracket twice, and then you can decide which brackets you want to multiply first. Okay, so since we've already done how to multiply out brackets, I'm just going to do a bit of a shortcut, not show everything multiplying out. So squaring this bracket will give us a squared plus 2a plus 1, and we want to multiply that by 2a plus 1. So then again, everything in here multiplied with everything in there, so that gives us 2a to the power 3 plus a squared plus 4a squared plus 2a plus 2a plus 1. Okay, so then all the a cubed, we elect our like terms, so 2a cubed plus 5a squared plus 4a plus 1. Okay, and that's our answer. Now if you got stuck somewhere or didn't follow along here, just do the longer way, write out both brackets, multiply it by itself, and then multiply that answer in. So a squared times 2a, a squared times 1, etc. 2a times 2a, 2a times 1, 1 times 2a, 1 times 1. And that should lead you to this answer. Alright, question C. So that's going to be 2 minus 3x to the power 4. Okay, 2 minus 3x to the power 4. Okay, so for this one, if you want to torture yourself a little bit, you're welcome to do that by writing out this bracket 4 times, multiplying out 2 brackets, multiplying that answer by the third bracket, multiplying that answer by the fourth bracket. That's going to take you some time, but you're welcome to do that. That actually might be a good idea for preparation, just to do that. Multiply everything out. So write down the bracket 4 times and multiply it out, and see what you get. And then compare it to the shortcut method, which is from the binomial theorem. So a couple of ways we can think about the binomial theorem, and probably one of the nicest ways is from Blaise Pascal, which is, we use the Pascal's triangle. It's named for that. So it works like this: 1, 1, 1. You start off like this. Always start with a 1. Then you add the next two numbers. So 1 plus 1 is 2, and then you end with a 1. Start with a 1, add the next two, add the next two, end with a 1. And you just keep going like this, right? 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and this is a triangle that continues going like that. So what does this represent? Well, this represents the coefficients of the terms that we'll get if we multiply out. So this is for if you've got something like a plus b to the power 0. That's also just going to be 1, right? Here we've got a plus b to the power 1 for this row. So what does that tell us? That's a coefficient. So a plus b to the power 1 is just a plus b. So 1a plus 1b. So that's what these two coefficients mean. Now a plus b squared, that means we've got 1a squared plus 2ab plus 1b squared. So that's the 1, 2, 1. And then to the power 3. So if we've got this, we've got 1a to the power 3 plus 3ab squared plus 3a squared b. Sorry, the other way around. And then plus 1b to the power 3. So these are the coefficients of the terms. So this will tell you also how many terms. So we've got to the power 4, right? So we've got a plus b to the power 4 in our question. So we know these are going to be the coefficients. Let's see, how does that give us the answer? So, well, in our case, the a is the 2 and the b is the negative 3x. So we've got, so we see we're going to use this one, right? Because it's to the power 4. So we're going to have 1a to the power 4 plus, and then 4a to the power 3 b to the power 1. So we see that a's value decreases each time. So if we had this, let me just expand this one. So we're going to have 1a to the power 4 and b to the power 0, but with b to the power 0 is just 1. But that's the idea, and you'll see that a's exponent decreases with each term and the b's exponent increases with each term. So plus 4a, and now 4 minus 1 is 3, and then b, 0 plus 1 is 1. Then 6a, and we subtract 1 from the a's exponent again, we add 1 to the b's exponent. Plus 4. We subtract 1 from the a's exponent, add 1 to the b's exponent. Plus 1. Subtract 1 from the a's exponent, add 1 to the b's exponent. So that's the idea, right? Okay. Then we've got the next term is the 6, so we've got 6a to the power 2, so subtract 1 from the exponent, b, add 1 to the exponent, so 1 plus 1 is 2. Okay, let me just get rid of some of this, make some space. Then plus 4a, subtract 1 from that exponent, that's just going to be 2, and then add 1 to the b's exponent. And then finally, plus 1b, so a to the power 0 is just 1, and then b to the power 4. Okay, and let's simplify that a little bit. Okay, so 2 to the power 4, 16. And then 2 to the power 3 is 8. 8 times 4 is 32. 32 times negative 3 is negative 96x. And then, so we've got 2 squared is 4. 4 times 6 is 24. And then negative 3 squared is 9. So 9 times 24, that gives us 216 x to the power 2, right? X squared. Then, so negative 3 to the power 3 is negative 27 times 4 is negative 108 times 2 is negative 216 x to the power 3. So we see the x's increase in exponents each time, right? X to the power 0, x to the power 1, x to the power 2, x to the power 3, and the last one will be x to the power 4. So negative 3 to the power 4 is 81, and x to the power 4. Okay, and that's it. So you see, this just takes 2 lines, nothing too complicated here. If you were to multiply this bracket out by itself 4 times, that'll take you lots of steps and lots of ugly things in between. But you'll get to the same answer. So maybe do that just for a check, just to check that you do get to the same answer. Okay, so that was question C. On to question 3. Question 3. What are we doing? Rationalizing the denominator again. Okay, so we've already done a couple of these questions, so we should go through these fairly quickly. So 3 plus square root 3 over square root 12 plus square root 3. square root 12 plus square root 3. So again, we're going to multiply by the conjugate, so square root 12 minus square root 3 over square root 12 minus square root 3. Okay, so multiplying the tops, 3 times square root 12 is 3 square root 12. 3 times negative root 3 is negative 3 root 3. Square root 3 times square root 12 is square root 36. And then square root 3 times negative square root 3 is negative 3. At the bottom, square root 12 is 12. And then the middle terms will cancel out as we know. And then square root 3 times negative square root 3 is negative 3. Okay, at the top, collect our like terms. Yeah, so let's simplify. Square root 12 is the same as 2 square root 3. So that's going to be 3 times 2 square root 3 minus 3 square root 3. Square root of 36 is just 6, and then minus 3. Over, and 12 minus 3 is 9. Okay, so that gives us 3 times 2 is 6 square root 3 minus 3 square root 3 is going to be 3 square root 3. And then 6 minus 3 is 3 over 9. So we can factor out a 3, which will leave us with square root 3 plus 1 over 9. So the 3 and the 9 can cancel out, which leaves us with square root 3 plus 1 over 3. Okay, and again, I'm doing more steps than what is necessary, but hopefully that is useful to some of you. Question B. 3b, got 2 root 2 plus root 8. 2 root 2 plus root 8 over root 8 minus root 2. Root 8 minus root 2. So here again, we can first simplify the roots a little bit if we like, or we can just straight up multiply by the conjugate. I don't know which one is quicker. I'm going to simplify the roots first a little bit. So 2 square root 2, and then square root 8 is also 2 square root 2. And then, so square root 8 we said is 2 square root 2 minus square root 2. So this actually works out really nicely, because we've got 2 square root 2 plus 2 square root 2, which is just 4 square root 2. And 2 square root 2 minus square root 2 is just square root 2. So the square root 2's cancel out, and we're just left with 4. Let's just quickly check what would have happened if we multiplied by the conjugate straight away. So if we did square root 8 plus square root 2 over square root 8 plus square root 2. That would have given us, so 2 square root 2 times square root 8 will be 2 square root 16. And then square root 2 square root 2 times square root 2 is 2 times square root 2. Well, 2 times 2, sorry. 2 times square root 2 times square root 2. So there's 2 times 2. Then plus square root 8 times square root 8 is just 8. Well, that doesn't look like an 8. And then square root 8 times square root 2 is again square root 16. Over, and then square root 8 times square root 8 is 8. And then minus square root 2 times square root 2 is 2. So that gives us square root 16 is 4. 2 times 4 is 8. Plus 4 plus 8 plus square root 16 is 4 again. Over 6. Okay, so 8 plus 4 is 12, plus 8 is 20, plus 4 is 24. 24 over 6 is also 4. So we see it works out to the same thing. Obviously in this case, just simplifying the roots first was a little bit cleaner, I think. But the nice thing is it does work out to exactly the same answer. So either one is fine. As long as it's mathematically sound, there's no reason why you should prefer one method over another, unless it's because you understand it better. That's always a good reason. Okay, that was B. We're now question C. Let's do that over here. So we've got u minus 1 over, and then square root of 3 plus u plus 2. Okay, so let's multiply by the conjugate. So we're going to multiply by square root of 3 plus u minus 2 over square root of 3 plus u minus 2. So at the top, we'll get u times this, so it's going to be u times square root 3 plus u, and then u times negative 2, so minus 2u, then negative 1 times the square root of 3 plus u, and then negative 1 times negative 2 is positive 2, over, and then at the bottom, So this times this will just be 3 plus u. And then minus 2 times negative 2 is negative 4. Okay, so at the top, no like terms we can really collect. We've got u minus 1. So I suppose that's one thing you can do if you want to simplify it. You can say that's u minus 1 times square root 3 plus u. And then minus 2u plus 2 over, and then 3 minus 4 is negative 1. So we've got u minus 1 at the bottom. And I suppose, yeah, this is actually quite cool. We can factorize a little bit further at the top. So let's keep the u minus 1, and so we're actually doing grouping at the top, right? So we're grouping these two terms, and we're grouping these two terms. So grouping these square bracket terms, we get this part, 3 plus u, we get that part. Then we can take out a minus 2 here. Minus 2, what's left if we take out minus 2? U minus 1. Fascinating. And then u minus 1 at the bottom. So now we've got a common factor of u minus 1. So we can take that out as a common factor. And what's left is square root 3 plus u minus 2 over u minus 1, which can then cancel. So our final answer is just square root of 3 plus u minus 2. Very nice. Yeah, quite a sneaky problem, because to see that you can factorize the top with grouping, I think some people might have missed that. But yeah, good question. Good question. All right, question 4. Perform long division. Okay, so I'm just going to do the examples. I'm not going to explain too much about what's going on here. As we go through it, you'll see it's not actually that difficult. It's the same algorithm for dividing normal numbers. Like if we divided 500 by 25, right? We'd say 25 goes into 5 0 times, and 0 times 25 is, actually, let's pick something else that doesn't start with a 0. So let's say 729 divided by 3. Okay, so 7 divided by 3 is 2, and then we multiply back. So 2 times 3 is 6, and then we subtract. 7 minus 6 is 1, bring down the next value, 12. Then we take this again. So 12 divided by 3 is 4, and then 4 times 3 is 12. And we subtract that, so we get 0. Bring down the next value. So now we've got 9 divided by 3 is 3, and 3 times 3 is 9. Subtract, and we get 0, and that's done. So no remainder. So this is exactly the same algorithm we're going to use, just with algebraic things. So let's see how that works. So we start off with number A, so 5x to the power 4, then plus x squared. So we don't want to skip any of the x's, so I'm going to say plus 0x cubed, just so we have this placeholder here. And then plus x squared, then minus 1. So again, I'm going to say plus 0x, so we just have all the exponents, all the powers of x, from the 4 all the way down to the single one. So minus 1, and we want to divide that long division by x squared plus 3. Okay, so divided by x squared plus 3. Alright, so what we do is we start with this first term. So 5x to the power 4 divided by x squared. So you just divided by the first value here, by this thing. So 5x to the power 4 divided by x squared is going to be 5x squared. Right, so all you do is just this part. 5x to the power 4 divided by x squared. See, that can cancel with 2 of those, and it's 5x squared that's left, right? Okay, and then we take this 5x squared and we multiply it by this whole thing in front. So 5x squared times x squared first, which gives us 5x to the power 4. And then 5x squared times 3, which gives us 15x squared. So we want to write that underneath the x squared thing. So there's 0x cubed involved here. And then we subtract. Right, subtract. So 5x to the power 4 minus 5x to the power 4 is nothing. 0x cubed minus 0x cubed is nothing. X squared minus 15x squared is negative 14x squared. Okay, bring down the next values. So bring down this. So plus 0x and minus 1. Okay, now again we just take this negative 14x squared divided by x squared. and that gives us negative 14. Now, negative 14 times this whole thing in front again. So negative 14 times x squared is negative 14x squared. Negative 14 times 3 is negative 42. So again, write that where it should be, and then there's 0 x's. And now again, we subtract. So negative 14x squared minus 14x squared is nothing. 0x minus 0x is nothing. And then 1 minus minus, so 1 plus, negative 1 plus 42 is negative 1 plus 42 is 41. What's happening here? Okay. The negative 1 plus 42 is 41. And that's it. So we can't divide anymore because this now has a smaller exponent for x than this leading term here. So with x squared we could still divide. As soon as we have something less than an x squared, we can't go any further. So this is our remainder once we have that. So here is our quotient, and this is our remainder. Okay. Question B. So question B, put x to the power 4. X to the power 4, and then we've got x. So we want to write plus 0x cubed plus 0x squared plus x plus 1. Plus x plus 1. And we want to divide that by 2x minus 1. So 2x minus 1. Okay, so again, x to the power 4 divided by the front thing by 2x. So that's going to give... This is actually interesting. So we're going to get this in terms of fractions. So I'm just wondering, should I do it like this in terms of fractions, or should we do it slightly differently? Or should we do it as x minus a half? Let's do it like this. Okay, we'll get some fractions, but yeah, that should work out. But you can let me know in the comments the way you do it. I'm gonna. I don't know which version I want to do. Man, I'm not sure. Okay, let's change it up a little bit. So let's say instead of dividing by 2x minus 1, we're going to say, if we say 2x minus 1, that is pretty much the same as saying x minus a half. Can we say that? Okay, no, let's just stick to this. Let's stick to this. But again, there's a couple of ways we can think about this. Okay, so x to the power 4 divided by 2x. So that's going to be half x to the power 3. Right? Okay, and then we multiply this by the whole thing in front again. So half x to the power 3 times 2x is going to be x to the power 4. And then half x cubed times negative 1 will be minus half x cubed. So minus half x cubed. And then we're going to subtract this. So that's going to be nothing. 0 minus minus a half is positive a half x cubed. Okay, and then let's bring down the next values along. So plus 0x squared. Now half x cubed divided by 2x. So half divided by 2 is a quarter. And then x cubed divided by x is x squared. So now again we take this and we multiply it back with the front. So a quarter times 2 is a half x to the power 3. Quarter x squared times negative 1 is negative a quarter x squared. Okay, and again we subtract. We just repeat the process. So that minus that is nothing. And then 0 minus minus a quarter. So 0 plus a quarter is a quarter x squared. Bring down the next value. So that's going to be plus x. Okay, quarter x squared divided by 2 is going to be 1 over 8x. And then multiply the 1 over 8x back with the whole divisor in front. So 1 over 8 divided by 2 is going to be a quarter x squared. And then 1 over 8x times negative 1 is minus 1 over 8x. Again, we want to subtract that. So this minus this is nothing. X minus minus 8, 1 over 8. That's x plus 1 over 8. So that's going to be, what is 1 plus 1 over 8? That's 9 over 8x. Okay, and bring down our next value. Plus 1. So 9 over 8 divided by 2 is 9 over 16. So plus 9 over 16. The x's will cancel. Multiply this back. So that's going to be 9 over 8x, and 9 over 8 and 9 over 16 times negative 1 is negative 9 over 16. And again, we want to subtract. So this is going to be 0, and then 1 plus 9 over 16 is going to be 25 over 16. And that will be our remainder for this. Okay, so let me know if you got the answer in a different way, because you can get it looking a bit different, right? You can definitely get this to look different. For instance, if you had the answer 16 and then 8x cubed plus 4x squared plus 2x plus 9. If that was your quotient, that's the same thing. That's exactly the same thing as this. Well, it's very close to the same thing as this. So if you had something that looks sort of like this, not exactly this, this is wrong, but something that looks sort of like this. And if you had 1 over 16, 1 over 16 outside times that, then this is the same as that. So if you got this, let me know, and I'll be interested to see how you got there. Or if one of you did, instead of dividing by 2x minus 1, some of you divided by x minus a half, and then did something with the answer to get it to look like that or like that. Let me know about that. Because like I said, different ways to think about this and how to do it. I think I generally prefer just doing it like this and getting our answer straight away. Then we don't have to think about what we did to the answer or what other factors we need to include here. Alright, that was this one. Then question C. Okay, question C. We've got, where is that? X to the power 5, x to the power 4, x to the power 3. X to the power 5, x to the power 4, x to the power 3. And then the 0x squared and 0x's. So 0x squared and 0x's. And then is it a plus 1? Plus 1 and divided by x plus 1. So plus 1, and we want to divide that by x plus 1. Okay, so x to the power 5 divided by x to the power 4. Multiply x to the power 4 by the whole thing in front, that gives you x to the power 5 plus x to the power 4. Okay, subtract that. So we get nothing, and then for this, and then x to the power 4 minus x to the power 4 is nothing. That's 0. Okay, bring down the next value. So that's going to be, yeah, I suppose, yeah, we don't have to care about the zeros. We just bring down the next value. So that's going to be x to the power 3. So x to the power 3 divided by x is x squared. And then multiply the x squared in front. We get x to the power 3 plus x squared. Let's bring down that one as well. So 0x squared. And then we can subtract this again. That minus that is nothing. 0 minus 1 is negative 1x squared. Bring down the next value, 0x's. Then divide again. Negative x squared divided by x is negative x. And negative x times x is negative x squared. Negative x times 1 is negative x. And again, we want to subtract this. So that's nothing. 0 minus minus 1 is positive 1. X. And then bring down the 1. So x divided by x is 1. 1 times x is x. 1 times 1 is 1. And if we subtract that again, we get 0 at the bottom. So here's our answer. And the nice thing is it's pretty easy to test. If you multiply that by that, you should get this, right? So if you say this times this plus your remainder, so that times that plus 0 in this case must be equal to that, then you know you are correct. So in this case, at the top here, if we say that times that plus that, we should get this. So that's a nice way you can just test it. Okay, so that's the long division part. Factorizing. Okay, so factorizing, question A. So we start with 4ab cubed, 4ab cubed minus 3a cubed b. Okay, so we always look for a common factor first, and in this case there are common factors. So 4 and 3 doesn't have anything in common. But a, both terms have an a, so we can take out an a. Both terms have a b, so we can take out a b. What's left? So if we take out 1a and 1b from here, we're left with 4b squared. Minus 3, take out an a and a b from here, a squared. Okay, and that's it. This almost looks like a difference between two squares, but 3 doesn't have a perfect square root. So, sorry. So we are done. That is our answer. Okay, b. X to the power sorry. So we've got x to the power 4 minus 81y to the power 4. This is the difference between two squares. So the difference between two squares is basically just something that looks like this. Right, you've got something squared minus something squared. So if you can write your thing as something to the power 2 minus something else to the power 2, then you know the answer will look like this. Two brackets, one with a plus, one with a minus, and then it'll be triangle, triangle in the first space of each bracket, and then square, square in the second one. So that is how you factorize the difference between two squares. So we can see here, just to show you exactly how it works, x to the power 4 is the same as, whoa, not a 2, it's the same as x squared, minus, and this 81y to the power 4 is the same as 9y squared. So we can see this is going to become two brackets. One gets a plus, one gets a minus. And then just like here, if it was triangle squared, now it's x squared squared, so it just becomes x squared and x squared. And then in the second part is the second thing. So what's in here is 9y, right? So 9y and 9y. And that's it. Oh, sorry. That's a square and that's a square. Square here. My bad. So now, this is again a difference between two squares, right? So this is a sum, it's a plus, so it's not a difference, so we can't do anything here. But this part is again a difference between two squares. So one gets a plus, one gets a minus, x squared, so it's just x and x. 9y squared is the same as 3y squared, right? So it's going to be 3y and 3y. And now that's done. So that's our answer for this one. All right. Question C. Where are we now? 64 a to, oh, this is a bit more of a tricky one. 64 a to the power 6 minus b to the power 6. Okay, so again, you can do this difference between two squares, because 64a to the power 6 is the same as 8a cubed squared minus b cubed squared. Okay, so yeah, so let's start it off like this, because you could also see it as a difference between two cubes, but let's start it off like this. Okay, so we know it's going to be two brackets. One gets a plus, one gets a minus. Then over here it's 8a cubed, 8a cubed, and then here it's b cubed, b cubed. But both of these, this is actually not that common of a thing to factorize, but this is, both of these can factorize further. So the rules here are, if we've got something like this, sum of two cubes, that becomes two brackets. So in here, we've got the cube root of both. So it's just going to be a plus b in here. Then in the next bracket, it's the first term squared. So a squared. Then it's the product of these two. So a times b is ab, and you change the sign. So instead of positive ab, it becomes negative ab. And then the last term is this second term squared. So b squared is b squared. Okay, so that's how you factorize this sum of two cubes. Difference of two cubes, very similar. So if you've got something cubed minus something cubed, you again get two brackets, a small one and a big one. And now you'll have a minus b in the first bracket because it's a minus. And again, you square your first term, multiply these together. So a times negative b is negative ab, and you switch the sign, so it becomes positive ab. And then negative b squared becomes positive b squared. So it's very similar. And that's exactly what we want to do here now. So this thing becomes two brackets, a small one and a big one. And this also becomes two brackets, a small one and a big one. Okay, so for this part, we're going to have the cube root of 8a cubed, which is just 2a. So 2a plus b, right? So the cube root of each thing. Now 2a squared, it's going to be 4a squared. 2a times b is 2ab, change the sign, so negative 2ab. And then positive b times positive b is positive b squared. Alright, now this one again, this is the cube root, so it's 2a minus b. Then 2a times 2a is 4a squared. 2a times negative b is negative 2ab, switch the sign to become positive 2ab. And then negative b times negative b is positive b squared. Okay, and then that's it. That is how you do it. So this is a pretty tricky question. I'm guessing most people got to this part, but then didn't realize you can do sum and difference of two cubes, unless you learned that again this year. I'm not sure exactly what was in the syllabus this year, but this you learned in high school at some stage, and then probably never touch it again. This is the sum and difference of two cubes. So hopefully this helps you. Here's in blue, that's basically the rule. Something cubed plus something cubed, that's how you factorize that. Something cubed minus something cubed, the same thing. Only difference is a sign somewhere. Okay, so that was the factorizing. Okay, 2 more questions for this tutorial. I know it's getting a bit long, but just hang in there. Question 6. 6a. Find the value of a for which x plus 2 is a factor of, so 2x cubed plus ax squared minus x plus 6. Okay, so they're telling us x plus 2 is a factor of this. Okay, so what can we do with that? Well, the theorem states that if x plus a, let's do x minus a. I think the theorem usually goes if x minus a is a factor of f of x, of some function, then f of a equals 0. So this is your theorem. Now let's see, what does that mean in practice? Let's actually highlight this and just change the color so we know that's sort of a theorem that we're working with. Okay, so that's our claim. This is true, this black part. So how do we get from here to here? Well, we said that we took x minus a equal to 0 and then solved for x. So x equals a if you take that over. So that's how we know this is what should come in here. So we're going to do the same thing for our question. We're going to say x plus 2 equals 0, the thing that they claim is a factor. So to take it over, it becomes negative 2. Right. So then we know that f of negative 2 is 0 if this is a factor. Then we can just plug that into our formula. Right, so we can just replace x with negative 2 and put it equal to 0. So this means that 2 times negative 2 cubed, so we're just replacing the x with negative 2 each time, plus a times negative 2 squared, minus negative 2 plus 6 equals 0. And it equals 0 because it's a factor. Okay, so let's simplify. Negative 2 cubed is negative 8 times 2 is negative 16. Negative 2 squared is 4, so plus 4a. Oops, 4a. And then minus 2 is positive 2, and then positive 6 equals 0. So 4a equals, so it's negative 16 plus a is negative 8, take it over, it becomes positive 8, and divide by 4, so a equals 2. Right. So if we do this, this is what the remainder is. So if the remainder is 0, it's a factor. So that's why we can call it a factor if this is true. Okay, so that was question A. And then B, they tell us when 4x to the power 4 minus 8x cubed plus 14x squared plus 8x minus 15. Oh, no, I combined question 6 and 7. Sorry, my bad. Question B. So 4x to the power 4 minus x cubed minus 2x plus b. When that is divided by x plus 1, the remainder equals 1. Okay, so again, what we want to do is we want to set this equal to 0. So x plus 1 equals 0, which means that x equals negative 1. So this is how we know what we're going to replace the x with. So this means that f of negative 1 is going to be 1, because that equals the remainder. It's going to be 1. If it was a factor, the remainder would be 0, right? If it was a factor. So if the remainder is 0, then we have a factor. But we're told the remainder is 1, so we just put it equal to 1. Straight up, just as easy as that. You don't have to do any long division here, but you can as well. It'll turn out to the same thing. So we replace the x with a negative 1 minus negative 1 cubed minus 2 times negative 1 plus b equals 1. That's our equation, right? So let's simplify. Negative 1 to the power 4 is 1, so 4 times 1 is 4. Negative 1 to the power 3 is negative 1. Negative negative 1 is positive 1. Negative 2 times negative 1 is positive 2. Plus b equals 1. So b equals 1. Minus 1 is nothing. Minus 2 is negative 2. Minus 4 is negative 6. So b is negative 6. Okay, and maybe do yourself a favor and test this with long division, and see if you can do it with long division. Might be easier for the first one to just do the long division and figure out what a is from there. But this is obviously the quicker way, just using this factor and remainder theorem. Alright, last one for this tutorial, question number 7. Okay, the polynomial x to the power 4 minus 8x to the power 3 plus 14x squared plus 8x minus 15 has x plus 1 as a factor. So x plus 1 is a factor. Use this information to fully factorize the polynomial. Okay, so we already know this is one factor, right? So let's do long division here. I think that might be the best way to go. Long division. Okay, so we're going to divide this by x plus 1. We know the remainder should be 0. So if we don't get a remainder of 0, we know we did the long division wrong, because this is a factor. Okay, so x to the power 4 divided by x to the power 3. X to the power 3 times this part in front gives us x to the power 4 plus x to the power 3. Then we're going to subtract this. That's nothing. Negative 8 minus 1 is negative 9x to the power 3. Bring down the next value. So 14x squared. Okay, negative 9x cubed divided by x is negative 9x squared. Multiply that back with the front values. And negative 9x, so it's going to be negative 9x squared here. Subtract. That's nothing. 14 plus 9 is 23. X squared. Bring down the next value, so it's plus 8x. 23x squared divided by x is plus 23x. Multiply that back in, so 23x squared, and then plus 23x. Oops. 23x. Subtract this. So that's nothing. 8 minus 23 is negative 15x. Bring down the next value. So negative 15x divided by x is negative 15. Multiply the negative 15 back. Get negative 15x minus 15. And subtract. And that gives us nothing, and that gives us nothing. So remainder is 0, so that's right. So we did divide correctly. Alright, so far we know this whole expression is then x plus 1 times x to the power 3 minus 9x squared plus 23x minus 15. So this part is already a linear factor, so that's nice, that's good. Now we need to factorize this part still. This is a little bit more difficult. So if you have a cubic thing, there's no real easy way to factorize this. So we first have to do some trial and error. Now how do we know what we can test? So we can test if we take this value, the value in front of the x cubed, so in front of the x cubed, and then the constant. Multiply those together, which will give us a 1 times negative 15 is negative 15. So we can test all the factors of negative 15. So we can try f of 1, well, all the factors of negative 15, let me just write them down. So it's going to be 1, negative 1, 3, negative 3, 5, negative 5, and 15, negative 15. So we can test all of those to see if any of them give us 0, because if they give us 0, we substitute it in, we know that's a factor, right, from our factor theorem. So let's try f of 1 first. So if we make x1 in here, in this thing, that gives us 1 cubed minus 9 times 1 squared plus 23 times 1 minus 15. Okay, so 1 cubed is 1, minus 9 times 1 is minus 9, plus 23 minus 15. So 1 plus 23 is 24, minus 9 minus 15 is minus 24. That gives us 0. So nice, first option works. So if f of 1 gives us 0, that means that x minus 1 is a factor. Right, so we know, so this implies that x minus 1 is a factor. How do we know it's x minus 1? Well, because if we say x minus 1 equals 0, we get x equals 1, right? So that's that thing here. Okay, so x minus 1 is a factor. So now we can take this thing again and divide it by x minus 1. So x cubed minus 9x squared plus 23x minus 15 divided by x minus 1, because we know x minus 1 is a factor of this thing. So we should again get a remainder of 0 because this is a factor. X cubed divided by x is x squared. Multiply the x squared back in, so x cubed minus x squared. Subtract this. We get nothing here. Minus 9 plus 1 is minus 8 x squared. Bring down the next value, so plus 23x. Minus 8x squared divided by x is minus 8x. Multiply that back in. And then minus 8x times negative 1 is plus 8x. Subtract. So that's nothing. 23 minus 8 is 15x. Bring down the minus 15. 15x divided by x is plus 15. So then multiply that back in and subtract. And we get 0, remainder 0, so that's correct. Okay, so what do we have so far? Well, we know this was our first factor, so we've got that part already. So we've got x plus 1. Then we saw from here we could extract a factor of x minus 1. So that's also a factor. And now what's left is this part. X squared minus 8x plus 15. Okay, so we just need to factorize this part still. Luckily, that's just a quadratic trinomial. So we know it's going to be 2 brackets. We know it's going to be x and x. And then the factors of 15 are either 1 times 15 or 3 times 5. And we need to get negative 8 in the middle. So if we have negative 3 minus 5, that's going to give us negative 8, which is what we want. And negative 3 times negative 5 is going to give us positive 15, which is also what we want. That's going to be minus 3 and minus 5. And that is now fully factorized. Fully factorized. Again, if you had a shorter method to do this, quicker way to do this, let me know. But I think this was quite nice. Covered long division, covered the trial and error method for cubic factorizing, and then some long division again, and then quadratic trinomial factorizing. Alright, so that's it for tutorial 2. Again, let me know if any of these things, if you have questions on different methods, or if you tried something else and got to the same answer, please let me know, we can discuss that. Alright.